Hello everyone, and welcome to the first main theory lecture of our section on pandas. In this one, we're going to start by taking a look at the series data structure, which is one of the two primary data structures available in pandas, the other being data frames. We'll build upon what we learn about pandas and series in this lecture, and then look at data frames in the following two lectures. So I hope you're excited here, and let's move on over into our Jupyter Notebook and get started. As mentioned, a series is one of pandas' two main data structures. So it's a one-dimensional array object that contains a sequence of values. And it's actually very similar to the NumPy vectors or one-dimensional arrays that we looked at in the last section. And behind the scenes, the Pandas series is actually built on top of the NumPy array object. The difference between the two is that the Pandas series can have axis labels, meaning that it can be indexed by a label as opposed to a number location. And it's also not limited to holding only numeric data types. I'm going to start by importing NumPy as NP, and then next I'll import pandas. And the common alias that you'll see used for pandas is PD. Something to add here is that you don't need to import NumPy in order to use pandas, but you'll probably find that it can be helpful to import both, as you might need to use NumPy to create data structures or any other such operations. Okay, and with our libraries imported, we'll have a look at how to create series. We can create series from either manual input, NumPy arrays, lists, or dictionaries, and we'll start here by looking at manual input. To create a series, regardless of whether we use a NumPy array, a dictionary, or any other way, we'll always need to start with the pd.series function. And notice here that I've used a capital S for the series, so it's important that we use capital. If we bring up our Shift tab documentation, we can see that the series function takes in quite a few different parameters. But for now, we'll focus on the first, which is just the data. For our data, we'll just provide a list of numbers, like so. And then if we run this, it'll return our pandas series. And it does look quite similar to our NumPy vector that we looked at last time. The main difference is that here we get a clear index. So our index of 0 maps to the number of 3, index 1 to number 7, and so on. We can view the data in our series by calling the array attribute, which also returns the length and data type of the object too. Alternatively, we can also view the indexes of our series by calling the index attribute, which we can see returned here. This then brings us onto one of the big advantages of Pandas series, and that is that we can actually specify a custom index. So if we copy our existing series here and then create it again, we could actually pass in another parameter, which is the index. And then here we could say that our index is equal to A, B, C, and D. Before I run the cell, I'll just quickly assign the result of this to a variable, and then we'll have a look at the output. We'll see that we have the same data on the right, but then for our index on the left, instead of the numeric list of 0, 1, 2, and 3 for our indexes, we now get our specified index of A, B, C, and D. And this means that we can then index our series off of our newly created index. So if we just say series at index B, this will then return the value at that index, which is 7. Before we move on to looking at how to work with the data in our series, I'd like to show you the other 3 ways that I mentioned to create our series, which was from a NumPy array, from lists, or from dictionaries. I'll go ahead and create all of these data structures now. So a NumPy array with 6 numbers going from 10 to 60, a list with the same values, and then finally a dictionary with the same values, and then also keys going from A to F. And finally, I'll also make a labels list containing some labels for our series 2. To create a Pandas series from a NumPy array, we can just say pd.series and then pass in the name of our NumPy array, which was simply called np_array. And then we'll get our result below. Before, we passed our index labels into the function as a list, but it's also possible to pass them in as a variable, and this looks a lot neater and a lot nicer. So all we'd have to do is add in index is equal to labels, and then labels is the list that we created up here. And then just to quickly show you, as the order of parameters for our series function comes in the order of data and index, as we can see here, we don't actually need to manually define the fact that this is what the index is. We can just pass in the data and then the labels. And then to create a series from a list works the exact same way as it did for our NumPy array. We'll just say pd.series and then pass in the name of our list followed by the labels variable for our index. With dictionaries though, something interesting here is that when we make a series off of our dictionary, Pandas will automatically create and assign an index or labels based off of the keys in that dictionary. For instance, if we have a look at our dictionary here, it's got 6 key value pairs, with our keys being from letters A to F, and then our values just from 10 to 60 again. If we turn this dictionary into a series and then have a look at the output, we'll see that the labels have been set to the key, and then the data is the associated value of that key. So this is a very quick and nice way to make a series. Something that I mentioned earlier is that Pandas series can actually hold multiple different data types, unlike NumPy arrays, which can only hold numbers. And just to show you this, if I create a new series here, I can pass in strings, numbers, and then even functions will work completely fine. Okay, and I'd also like to show you that if you need to, it's possible to convert our series objects back into either lists, dictionaries, or NumPy arrays. If we take our series from before, we can just call either the tut_dict, tutlist, or toNumPy methods, and that will convert our series back into dictionaries, lists, or NumPy arrays respectively. And you can see what that looks like on screen here for each of these examples. And moving on, another important topic to cover is how to index our Pandas series. Indexing a series works in a very similar way to indexing a Python dictionary. Instead of just providing an index number, you can actually provide a label like we said before. To demonstrate this, I'll create a new series containing some information on different countries and their population. So I'll create this with the pd.series function, and then our data will be the population figures, and then the index will just be the names of those countries. If you'd like to copy these numbers and labels into your own notebook, then you can find this code within the notebook for this lecture, which is just called 01 series, which is the lecture 1 notebook within the Pandas section folder. And then this here is the output of our series. Instead of passing in a number to index this, we could actually pass in the name of one of our labels. So either the USA or the UK, for example. And this will then return the population of that country. So this is a very quick and easy way to return information from a series. The final thing that I'd like to show you in this lecture is that we can also perform mathematical operations on our series too. Let's go through and create one more series, this one on country GDP data, and then again, I'll just copy over the data that's already in the notebook file for this lecture. Okay, great. So we've now got 2 series here, one containing information on different countries and their populations, and another on countries and their GDP. and GDP is just the gross domestic product, which is just a measure of the monetary value of the goods or services produced by a country within a given period of time. And note here that in our country population series, we have Canada, and this country is not in our GDP series. And then similarly, in our GDP series, we have data for Australia, but this country is not in our population series. And we'll see why this is relevant shortly. Let's use these two series to work out the GDP per capita for each of our countries. And GDP per capita is just an economic metric that can be used to determine a country's economic output per person. To calculate it, we can divide a country's total GDP by its population. So here we can say GDP per capita is equal to the country GDP divided by the country population. And then if we take a look at our result, we'll see that Pandas has divided the GDP by the population series. Interestingly though, we can see that Australia and Canada have an NaN, or not a number value. And this is because operations performed on series are performed off of the label. So if the label isn't present in both series, like we have here, then the operation cannot be performed and an NaN value is returned. But for values where there is a label in both series, it's then gone through and divided the GDP by the population. Okay, so that's the basics of series and how they work in Pandas. It's important to have a basic understanding of them and how they work, but for the most part, we'll be using data frames as our main data structure. Let's go ahead and wrap this lecture up, and then in the next one, we'll begin having a look at data frames.